Welcome to this lesson on understanding proportions. Today we're going to talk about creating proportions and then finding if two proportions are or two ratios are proportional. Right, so first off, it's important to know what is a proportion. A proportion is an equation stating that two ratios are equivalent. Right, so here are three examples. So you have the ratio 2 to 1 is equivalent to the ratio 6 to 3. And 2 to 1 is also equivalent to the ratio 4 to 2. Notice the way that I'm saying it. It's not 6/3 or 4/2 because these aren't fractions, they're ratios. So when you look at it, they look very much so like equivalent fractions, but they're ratios that are equivalent. And because they're equivalent ratios, we call those proportions. Right? So when you think of proportional, what you're looking at is, what you do to one thing, you have to do to the other. So if you take a picture and you stretch it, so if I take this picture here, let me see if this will work. If I take this picture here and I just make it longer, it is no longer proportional. If I take it and just make it wider, it's still no longer proportional because I'm not doing the same thing to the length as I did to the width. However, if I grab this corner here, it does the same thing to the length as it does to the width, making this shape here proportional to all the others since they were the same size. So they're no longer the same size, but they're proportional because of the fact that maybe all I did was double the length and double the width, making them equivalent and proportional. Right? And I always love to give this example when we talk about whether or not things are proportional. Think about a Tyrannosaurus Rex. Tyrannosaurus Rex has a very large head. No, ignore my drawings here because they are terrible. Okay? And then you've got this big old body. And here we'll do some teeth. He's starting to look more like a crocodile, I guess. And then he's got these little itty bitty arms. That is a fantastic T-Rex, if I do say so myself. All right, so the arms of the T-Rex are not proportional to the rest of its body. And you think of how hard that would be to do anything with. You couldn't even reach past your own face. Right? So that's something that would not be proportional. All right, so we're going to write a ratio for this model. Remember, a ratio is something that compares two quantities. So we're going to compare the quantity of hearts to the quantity of stars. So here we have 4 hearts to 2, 4, 6, 2, 4, 6, 8 stars. And then what we're going to do is we're going to take these hearts and these stars and we're going to separate them into equal groups. Okay, so it's not that I'm saying I need a group of, so I have 12, a group of 6, and a group of 6. No. However many hearts are in the first group is the same number of hearts that need to be in the second group. So if I take a heart and put it into the first group, I need to take a heart and put it into the second group. And heart and heart. Right, and then now we have the stars. Okay, so now what I did is I took this and I said, okay, well, this is equivalent to taking 2 of the hearts and 4 of the stars and putting them into 2 equal groups. So the proportion here tells me that 4 to 8, so 4 hearts to 8 hearts, is equivalent to 2 hearts to 4 hearts. Okay, so you can work backwards when you work with proportions. You can make it smaller, and we can even go smaller and say, okay, well, here I can take it and do 1 and 2 and 1 and 2 and so on, and then take these and do the same thing. So basically what you're doing is you're saying, okay, well, if I can take this and split it into separate groups that have, and it has to be 2 separate groups, and they have to have the same amount of hearts in each and the same amount of stars in each or whatever you're working with, and there has to be none left over. If there's some left over, then it's not really going to work unless you break it into decimals. Okay, another way to look at this is to look at a tape diagram, and I know it says example 2 and it's a you-try problem, but I want to show you a tape diagram real quick since we've talked about these in the past. So when you're looking at something that's proportional, you're saying that if this is 2 to 3, so we have the ratio 2 to 3, so each of these right now is worth 1. Well, if it's proportional, then now each of these is worth 2, so each of these has to be worth 2. So 2 to 3 is proportional to 4 to 6. So you can work the opposite way as well. Okay, so I'm going to take a look at this and try to write a proportion for this model and see what you can come up with. When you come back, we'll check your answer. All right, so I'm going to do triangles to circles. So if I do the ratio of triangles to circles, I get 4 to 2. And then I can take these and put them into a group of 2 and 1, and then 2 and 1, so I know that 4 to 2 is proportional to 2 to 1. Now, could you have done circles to triangles? Absolutely. Okay, so this is a lot like when you make equivalent fractions, except for now we're talking about equivalent ratios, and when you have two ratios that are equivalent, we call them a proportion. And we're going to take this further when we talk about scale drawings and things of that nature, but right now it's really just making sure that we understand what is a proportion, or what makes something proportional. All right, so let's see if we notice something here. What I want you to do is I want you to help me fill out this chart. We'll fill out the first part together, and then you are going to fill out the last 4, and we're going to see what conclusion you come to. So the numerator on the left. So for number 1, the numerator on the left is 9. And the denominator on the right is 2, and the product of those two is 18. The numerator on the right is 3. The denominator on the left is 6, and the product of those two things is 18. So I want you to go through and do the rest of these, and when you come back, I want you to we'll check your answers, and I want you to think of a conclusion that you've come to that is true for all proportions. And write that conclusion down so we can talk about it when you come back. All right, so what you should have come up with is this. Oh no, they go away. Okay, so you have 3 and 15, which gave you 45, 9 and 5, which gave you 45. Okay, so you're really just taking the cross numbers here. And then you should have noticed that every time that you multiplied them, they gave you the same product. Now, they didn't give you the same product every time, obviously, because they were different numbers, but within each proportion, each cross, and we call this cross multiplication actually, so each time you did cross multiplication, it gave you the same number within your proportion, or the same product. So the conclusion that you should have come to is that in any proportion, when you do the cross multiplication, your products should be equal to each other. No matter what the numbers are, your products need to be equal, and that helps you determine that this is indeed a proportion. Okay? Yes, we can look at this and say, oh, 14 divided by 7 is 2 and 7 divided by 7 is 1. However, we're going to work with numbers that it's not going to be so easy to see. So you'll find that it's really nice that we're using easier numbers here to get the understanding of it. But at times, we might be working with a proportion that's something like 3 to 2 is equivalent to 1/2 to 1. This might not be something that is, easy for all people to see. Or 4 and 5/10, and then, so you're multiplying by, here, I know, you're multiplying by 1/2. Okay, so it's like, oh, well, how do I know for sure if this works or not? Get rid of that. So I can easily see that 2 divided by 2 is 1, and 3 divided by 2 isn't going to be 4.5, but now what if I put something like 1.5 here. How do I know if this is proportional if I don't know if what I multiplied worked? Okay, and actually, what if I put 2.5 here? How do you know if these things are proportional or not? Okay, that's kind of what we're going after here. It's a little bit hard to conceptualize right off the bat, but as we move along with it, it'll make more sense. Okay, so cross product, this needs to go in your vocabulary. Cross product is the two products found by multiplying the numerator of each ratio by the denominator of the other ratio. Okay, so here's your definition, and then you don't have to write all three of these examples. You can just write one of the examples. That is absolutely fine. Again, pause so that way you have time to write it down, but I am going to move on. All right, so we have a couple more examples here. And what I would like you to do is I would like to do this one with you, and then the last two you're going to try on your own. Now, the last one, you actually have to set up your own proportion and then see if it is proportional. You have to set up your own equation and see if it's proportional. So you have to make sure that what you put on top and what you put on bottom is the same. So, we're talking about 30 students in the classroom, and 14 of them are girls. So if there are 90 students, 42 of them are, girls, and we're trying to see if that's correct. So when you set up your proportion, if you put students on top on this side, you have to put students on top on this side, and you have to make sure, so 30 goes with 14, so those two pieces have to be together as well. You can't mix around your numbers. So you are going to have a little element here of trying to work through that part of it on your own. Okay, and then again, you'll have a problem here to work on your own as well. All right, and then we're going to use cross products to see if the ratios are proportional. As always, you can go ahead and work through this problem and come back and check your answer. If you're all set to go, then by all means, go ahead and move right along. All right, so first I'm going to go ahead and look at what I have to multiply. And in this case, I have to do 4 times 12. And I have to do 3 times 16. Here, I know I get 48. 3 times 16, I'm not quite sure off the top of my head, so I'm going to take 16 and multiply it by 3 because it's multiplication. I can put the 16 on top. 6 times 3 is 18. Carry the 1. 1 times 3 is 3, plus 1 is 4. Since both of them equal 48, I can determine that, yes, they are proportional. And I would want to write out in a complete sentence that they are proportional because their cross products are equal. Products are equal. Okay, so that would be a good explanation of why you know that they are equivalent or that they are proportional. All right, so as I said before, you are going to do problem 4 and then the word problem on your own as your U-tries. As always, if you have any questions, please be sure to email me and write them down so we can go over them in class.